I would like to open the floor first to Andreas and then to Rolf, so they can say a few words extra about themselves if they'd like. So Andreas, you can start.
Yeah. Thank you, Justin. Just to say that I'm very happy to be here. I feel very happy to have been invited to this roundtable. Well, yeah, ready to talk.
Thanks, Andreas. And then Rolf, is there anything else you'd like to say?
Hello. No, I just would like to thank you for the invitation, and it's good to see you folks, and it's good to see Andres, and I'm happy to join this discussion.
Great. So Agnes, I believe you'll be asking the questions, is that correct?
Yes.
Yes, so I'll turn it over to you then.
Okay, before going into the questions, I would just like to let you know how the format of this roundtable is planned to be, and hopefully it will work out very well. I am looking forward to it, and I'm very, very glad that Andres and Rolf could make it to this discussion. So we will first go through some questions that we have prepared in advance for you. And we would like to listen to your opinion. You have both of you have a decades long already, I should say, experience with large-scale assessments data, and you've been involved in many discussions on the scientific level, but also with stakeholders and policymakers on different issues. And I think it's very interesting to listen to your opinion on some of these important points. And after there was the possibility for both of you to express your opinions and discuss, I would also, or we would like also to open the floor for the participants to ask questions or add also some comments. For the participants, of course, you need to be aware of the fact that it is being recorded, and actually the plan is to put this discussion roundtable on our social media. So it will be made available to the bigger audience. So just for you to know, and of course we appreciate if you ask questions to also turn on your camera and maybe say who you are, which organizations are you coming from. So we have a little bit more personal connection through this virtual meeting. So let me first start with the very first question that we have prepared. In the context of regression analysis, the argument is that through the creation of the so-called pseudo-experimental conditions, and this is of course through controlling for possible confounders, the coefficients are less biased and therefore a better approximation of the causal effects. And maybe you have heard already of these arguments. And in the context of multi-level modeling with ILSA, the argument is even strengthened and extended by the fact that MLM seems to suit the structure of the data very well. And also ILSAs usually offer a large set of available control variables. So we would appreciate to know whether, in your opinion, the specific argument could hold, and if you would agree that to some extent, this rigorous implementation of regression analysis those implemented in the MLM environment can be perceived as more reliable estimate of the causal relations or not. And I would just like to ask Andres to take the floor first, and then followed by Rolf's, and then we can switch around the order with later questions.
Good. Thank you very much, Agnes. It's a very interesting question. Particularly in the context of this workshop on multi-level models. And from my point of view, I would say that not necessarily. I think it's very important that we ask ourselves, why are we running multi-level models instead of single-level regressions or OLS models? And it is also very important to remember that there are several valid strategies to take into account the structure of the data. So we use multi-level models because the data is nested, but there are other ways of taking into account that, no? More prominently probably what the IDV analyzer does or what the method that is used for the international reports, no? And a number of them, these resampling methods, bootstrapping or jackknife or VRR, etc. So there are other ways in which we can take this into account. And then whether one or the other provides better estimates, I also think is a matter of other things and how we specify the models. They have different assumptions, and we have to make sure that we are meeting the assumptions. But there are also, we have to be very careful, particularly with multi-level models, for example, how we use all the information that is available. Something that I have seen very often in published research, for example, using multi-level models for international large-scale assessments, is that they specified everything, but they don't consider the stratification. Because you use the weights and you use the account for the weights and the nesting and no stratification. And it's very often what they do. Another thing is the weights, no? Like when you split the weights for one and the other level, and just because some software, some pieces of software do not allow to specify different weights in different levels, then people just don't do it. Or when you have 3-level models that we're still, I think they're only in M+ you can do it as you should, but in many other softwares you can't. So people just skip some parts of the rigorous specification of the models. And then while in principle, multi-level models can be a very powerful tool, it, I think, depends on how you use the information that you have available for it. And the same applies for the OLS models, no? Because there are also lots of assumptions that in many cases or in most cases is very difficult to meet. So I think it depends on both assumptions, that you can meet the assumptions, and that you use all the information about the design that is available into when you specify your model.
Yeah, if you allow me, I would like to join in now. Okay. Well, basically, I think I couldn't agree more with Andres. This multi-level models, they do not do any magic when it comes to the identification of causal effects. Even though I think that what is important is that when we estimate multi-level models, we often have a causal question in mind. We want to estimate some effects, some parameters, and typically we do interpret them as if they were causal effects. We hardly use the word causal effect, but typically that's what we mean when we estimate such a model. So I think we should be there honest to ourselves, and I think this is what we typically want to do. How successful are we when we do estimate a multi-level model? In general, I think what is more important is the research design. I agree with what Andres said. And however, I think that multi-level models are useful to think about causal questions. And let me give you an example what I mean. So a causal question is typically about some treatment variable. And that's the treatment variable X. And we want to estimate the effect on Y. And what we do in an experimental study is that we randomize X. So we flip the coin and put our participants of a study into two groups, and then one receives the treatment, the other doesn't. And so the allocation to the groups is just by chance, because we flip a coin. And so by implication, we will have two groups that are exactly the same, but one group receives the treatment and the other doesn't. This is the experimental condition. And the other thing is, now in an observational study, we do not do this randomization. And what we should always think about is if there are any selection effects. And selection effects make our life miserable, because the two groups will differ not only by the treatment status, that they received something or not, but also by other factors. And so what Agnes introduced in the beginning was that the two groups can now be balanced by controlling for other variables. And now comes the important point where I see the power of multi-level models. Multi-level models are the nature of multi-level models is that we have different levels, and this provides a conceptual framework. And we can now look at the individual level, typically at a classroom level, at a school level, at a country level. And I think this distinction is extremely useful because these selection effects can take place at different levels. There may be selection into treatment at individual level. Just think about kids that go to kindergarten. So the parents may decide whether they send their kid to kindergarten or not. And typically there's a selection bias by social background, by social class. Privileged parents send their kids to kindergarten more frequently. But that is only on individual level. And there are now other confounding factors. For example, on country level, there are some countries where only, say, half of the kids go to kindergarten, and other countries where almost all children go to kindergarten. And typically these countries differ. Typically the richer countries have a universal preschool system, while other countries that are not that rich do not have. And this is just another selection mechanism that we should think about. And multi-level models help us conceptually to distinguish between the different levels. And I think there's a great advantage.
Yeah, if I may add, Agnes, I think this is, I also agree with what Rolf says, and it's also important to think about the framework that multi-level models provide, because there are a set of questions that cannot be answered unless you are in a multi-level framework that could or could not have to do with causality. Like, for example, the cross-level interactions, questions about how the characteristics of a school can explain effects of at upper or lower levels. These kind of things you cannot do within a different framework. And multi-level models give you the opportunity, the chance, the framework to address these kind of questions. And I think this is really the value of it. It's not I would like to stress, it's not that one approach or the other is more correct. It's just that they provide you different possibilities to answer different questions, which is what we should, from my point of view, we should be focusing on.
Yes, thank you very much for this deeper insights into your thinking on this. And what I'm taking from this is, yeah, as always, the response is not that straightforward, but it could be under some circumstances, yes. And this is a good transition to the next question, because the next question focuses a little bit more on the conditions under which we could, or under which a study could provide sufficiently reliable estimates for causal mechanisms. And this is related to the fact that, as we all know, that with our statistical analysis in social sciences, we are always aiming at an approximation of the reality. So that this is true for any type of study and data education scientists are dealing with. And it's not actually the aim to provide a perfect picture of the reality, but the best picture we can get from our data. And the conditions you mentioned already a little bit around the quality of the models and the data we are dealing with. Maybe you would like to add something to this, but there's also two other questions related to this topic. First is whether coefficients with designs that are more suitable to assess causal effects, such as those from longitudinal study, differ in your experience considerably from the estimates obtained from cross-sectional data. And the background for this question is, of course, that there are several people or scientists who are very conservative in their opinion on how to assess causal effects. And of course, the only choice is the longitudinal design. And the question is whether this is really, this could be supported by empirical findings, namely by showing that there are big differences between the results obtained. And also, in the light of this discussion, how do you perceive the potential of alternative methods available at the present, for instance, matching methods and propensity score matching? And I think that Rolf has been involved in a lot into such an analysis. So I would now switch the order and ask Rolf to first take the floor on and to discuss these questions, and then ask Andres to also jump in and add to this.
Yes, sure. Thank you, Agnes. Well, so yeah, you just posed several questions. I'll just pick one of them, and I'm happy to elaborate on others. But let me start with the question on longitudinal designs. So I think there's the distinction between cross-sectional and longitudinal studies, and obviously the large-scale assessments like TIMSS, PEARLS, and so forth, they are cross-sectional studies. We test students only once, and we do not have a measure of prior achievement. So typically people say that longitudinal designs are better than cross-sectional designs, and I would agree that this is typically the case. Typically these designs are much stronger. However, is that always the case? No. Sometimes cross-sectional studies and longitudinal studies will give you the same results, and I've seen both. So I've seen that sometimes you observe strong correlation in a cross-sectional study, and then when you look at it longitudinally by controlling for prior achievement, the effects completely vanish, they disappear. However, I've also seen that the results do not differ, which brings me now to the lesson learned. You never know. You have to know you would need to have longitudinal data to test for it. And then in the end, it may well be the case that the results are still the same, but this is something you cannot say in advance. And therefore, I would say whenever you have access to longitudinal data, you should have access to you should use it and exploit this longitudinal component, and then you can still test whether its results have changed compared to cross-sectional findings. And yeah, well, but you learn little from this. You have to do the longitudinal analysis, I would say. I don't know, Andres, would you like to?
Yeah, I think, as I was saying before, it depends on the questions that you have, no? There are some examples in which longitudinal data is really an advantage, or a need even, but there are some other questions for which cross-sectional data is just enough. I don't know, I can think of the school effectiveness research and the value-added models and previous achievement, no? Which if you are interested in knowing which schools are more effective in terms of improving the learning outcomes of the students, then definitely having access to longitudinal data is gonna be very helpful. But if you are rather interested in more not causal or predictive studies, but more explanatory, if you want to understand what is the relationship between socioeconomic status and learning outcomes, and you want to divide that into cultural, economic, social capital in Bourdieusian terms, then you probably don't need longitudinal design, because what you are looking at is not you're not predicting anything, you're not trying to establish causality, but just to see, you're trying to see if a theory fits empirical data that you have, no? So I think it depends. It is, for some questions, useful, and for some others, I would say is not necessarily the case that you need it, no? Now, I also think that that brings me to another thing that I was thinking when I was trying to prepare some information to answer these questions, and it's something that has to do with the questions, that what we want to do. And I think that is going to change many things of how we approach the question. I think normally, in many cases, as Rolf was saying, you want to predict, or you want to infer causality. But I think there's a middle step between a purely explanatory story and a causal one. And this one is the prediction. Because if we go to the definition of these things, we could say that prediction is simply the estimation of an outcome based on observed variables. And causality goes a step beyond, which is the identification of the mechanisms that are underlying the associations that we saw. If we want to go to causality, and I think that is very important, if not indispensable, crucial, to rely on theory, because causal methods and experiments are not designed originally for social sciences. This is for exact hard sciences. So in society, we cannot control everything. We are not in a laboratory. We can approximate that, but we cannot reach it, never. So our measurements and our models and our estimations are going to be imperfect. From my point of view, the only way that we have to compensate for that is relying on theory, which is, by the way, one of the main criticisms that are normally posed to research and into large-scale assessments, or to the field of large-scale assessments in general, no? The lack or the weak that we establish with theory, which I do think that is very important, particularly if we want to talk about causality.
I would like to add something, because luckily I somehow disagree now. Well, I'm not sure if it's completely disagreement, but I think that we should distinguish clearly between two things, and I don't believe that something is there in between. I think one thing is descriptions. For example, kids of privileged from privileged households perform better in school than kids from disadvantaged households. That is just interesting information, and it is typically not in line with our ideas about social justice. So this is just an important piece of information. Same with gender differences, for example, or whatever, you name it. On the other hand, we have sometimes relations between some educational variables. For example, teacher education and student achievement. I think the only reason why we look at the relationship between teacher education and student achievement is that we want to determine whether teacher education is something effective, that it makes sense to invest 4 years into the training of teachers. And we are not interested in a comparison between the two groups, educated and uneducated teachers, like high versus low SES kids. But here this is a causal question. And I think that changes now the game, because now we should really try to think about whether we actually estimate a causal effect or not. And here we can think about selection mechanisms, like untrained teachers more frequently have disadvantaged kids, for example. This is something we would like to control for. And what we want to do there now about this effect is we want to control for everything that we can think of. If it's a multi-level model or something like that, then we would need to identify all the variables, all the possible confounding factors, or we would like to do an randomized trial where we assign students at random to different teachers, or we want to do a longitudinal study where we control for prior achievement, do all these things. But I think there are these two different things. We have descriptions and causal questions. And for causal questions, I think they are considerably more difficult to address. They are not necessarily more important questions. I think that should be clear.
I think we're not necessarily in disagreement, Rolf. What I was saying is that when we talk, or when people talk about causality, they are talking about prediction, not really causality. And I say that, going back to your example on the disadvantaged children, you can find an association between disadvantagedness or low socioeconomic status and achievement. And then based on that, you can predict that children from a lower socioeconomic status will get lower achievement. But if you don't know why, then you are not establishing causation. You're just predicting. It's like forecasting. I know I can predict that someone from a low SES is going to have lower achievement. If you really want to achieve causation, you must identify what are the underlying mechanisms that cause that someone from a lower socioeconomic status has lower achievement. And for that is what I was saying. For that, we need theory. Because then we can go to Bourdieu, as I was saying before, no? And we say, how do we define beyond what we have in the data set? How do we define socioeconomic status? As we know in IEA studies, in PISA studies, you say parental education, parental household items, and income sometimes you have in some studies, no? So, but what is that? What are we measuring with that? If we say we are measuring cultural capital with books and items at home, and then we can establish a theoretical explanation, a description of the mechanisms that produce that. I mean, we can talk about, you have more books at home, that means that parents read more, so they know more, they read to children at home, and you can establish those mechanisms. You have more things at home, you have more money that can give you access to different experiences, and that is what is going to cause that it's going to be easier for you to acquire new knowledge, and so on and so forth. But my point was rather that we have to be careful, and we have to aim for causality and not only for prediction. And this is the first point. And the second point is that I do think that we need theory in order to achieve that stage, because our measures, coming back to Agnes' first question, our measurement is imperfect, and our models are imperfect. We can try to control for as much as we can, but we will never succeed in controlling for absolutely everything.
Yes, thank you very much. It's very interesting, and I took some notes. And what I would like to stress is that I'm taking from this discussion for now that it depends on the kinds of questions. That remark I found very interesting, because it's also a good transition to the third question. But also, as you probably have noticed, and the participants as well, that there are different understandings of what causality actually is and how to define this. And this is not only something that we encounter, but it's also in the literature. There is a lot of discussion and a very pathetic discussions on this. So you will find even authors who would say that causality it's impossible to establish causality with any methods, and it's going really into different directions. But now I would like to a little bit more focus on the policy and implementation side of this longitudinal designs. And I was really thinking, like, if we say that longitudinal designs are the most desirable designs for at least for some kind of questions and for a specific definition of causality, namely when we are interested in the mechanisms, then how realistic you think that it is that in near future ILSAs will implement suitable designs for the estimation of causal relationships, given the costs and the extra work that is needed to have such a data, but also assuming that you both are aware of how the policy makers and stakeholders are perceiving the studies, and that their interest is on monitoring and evaluation of educational systems. What would be your advice on how we could encourage the countries to invest possibly more time and money into the assessment than in the years before, or how could they be convinced to comply with less topics covered for the same amount of money, for instance, because that would be the maybe the cost of implementing such a design. And I ask this question on purpose because I have in my mind that we will circulate this through our networks, and I'm really interested in encouraging policymakers and stakeholders to maybe consider investing more into this type of questions about the mechanisms, because I think that with nowadays ILSA, we have ILSAs on many different topics and conducted by diverse organizations. But I think that so we have a lot of information on descriptive level. So I think it's about time to go a little bit more deeper and to understand the mechanisms. So yeah, I would give the floor first to Andres now to switch the order again, and then ask Rolf to jump in and add to this.
Well, if you ask me how realistic it is that we are going to have the designs that we need to establish causal mechanisms, I think it is very likely. There is a matter of coordination and joining efforts towards, I mean, it's a matter of having all stakeholders to collaborate towards common objectives. And in that sense, I think that the IEA is in an unparalleled position to promote this kind of initiatives. I mean, there are a number of things that can be done and that have already been done in different countries. Now, one is that I can see to have, for example, longitudinal data is combining ILSA data with national assessments. This has been done in several countries, and I think this is something that do not require much more additional resources, because basically what they do is they apply the national, let's say, teams, and they do the national assessment on a different calendar, on a different timeline, or probably in some countries every year. So what they do is to take the sample from teams into the sample or the census, and sometimes they have census that they do in the national assessment. So they construct a panel or a longitudinal data set. So I think this is something that I see like a very powerful alternative, which some countries do, but is not the most common thing to do. And I think the IEA, for example, could promote these kind of practices and even go beyond than promoting, to provide technical expertise, technical advice, technical coaching to do these kind of things. And in that way, we would have a longitudinal data sets, but we would also have an expanded number of background variables. We wouldn't be limited to the variables that we have in the background questionnaires from teams, but we could add all the information that countries, administrative data has about the schools, students, teachers. So that would be very useful. And the second thing that I see is that if you link national assessments to international assessments, there's another thing that can be done, no? Which is you probably would not need, I mean, there are some research that has been done on that. You wouldn't need a country to participate in teams to have a team's score, but you would need a number of countries to be able to link the information. And that would expand the number of countries that we would have to compare exponentially, but that would also have very important implications, particularly for the organizations that are running these assessments, no? Because you would have less countries participating, and that probably would mean that you would need to shift the kind of services that are provided towards linking and towards analyzing data rather than applying data, more the research part, analysis part, than the collection of information or the processing of data. I think this is a big thing, a big step, but and there are many, it's not easy, no? There have been several attempts and unsuccessful attempts to do so. And there are some disadvantages on the approach, but I think it's something that we, if we are willing, all stakeholders, and I mean countries, different organizations, because we know organizations like the OECD, the IEA, UNESCO, UNICEF, all of them are doing this kind of assessments. If all of us, all of these stakeholders want to collaborate, contribute towards the same end, we could come up with original, interesting strategies to have better quality data.
Yeah, thank you. It sounds very interesting. I remember these discussions from the time when you were the unit head of the Randa unit at the IEA. And I remember we had already several discussions, or you also were discussing this with the management. And yeah, so it's not such a novel topic to us, but we still are not, we didn't arrive at a solution, at a perfect solution, because it would also, another implication of this would be that some countries, like these countries actually which participate in the study, would have to kind of pay while for obtaining the data, while other countries would probably not, because they would rely on the national assessment. So it has many implications also on the policy level, this change that you just mentioned. Rolf, do you have anything to add? I suspect so. Please go ahead.
Yeah, I think first, I think one important thing is what Andres already mentioned is be creative, combine studies in new original ways to establish interesting research designs. And I think you already mentioned a couple of things like combining with national data. I think that is a great approach, and I have a colleague working here with me who has done that, who has conducted a few magnificent studies where he combined data from, I think, PISA and something drug use in Mexico. And that is just a very brilliant study where he studies the effects of the drug war in Mexico. He has conducted very interesting studies on refugees in Slovenia, where he combined information about these camps for refugees with data from the ICCS study about civic attitudes, and where he just looked at if the distance to a refugee camp has an impact on how you think about refugees. And these are brilliant studies, and I think more research is needed there. And I think in particular, people that live in a certain country are best prepared to conduct such a study, because I have no idea about Mexico, about Slovenia and these countries. I just know too little about these countries. So I would really encourage you, I see that the participants here come from quite diverse countries, to think about your own country, what you can do in these countries, what data is existing. So that is one thing where I can only support Andres' call for more studies. I think there's quite some potential. However, I think that there are also other ways how to use the data from international studies that are already existing. Studies like TIMSS, PEARLS, and PISA, but also ICCS or ICLS, they have been repeated now a couple of times, and they have a longitudinal component on country level. And for me, the main advantage of international studies is that we can compare countries. And I think one of the founding fathers of the international assessments stressed that if we want to learn something about an education systems, one of the best approaches is to compare different educational systems, and having longitudinal study by repeated observations on a country level, I think we can make more use of this data. This is understudied so far. In this context, I can only recommend to you to look a little bit on what economists are doing. I think they have developed more sophisticated methods over the past decades. And I mean, you probably have heard of Rick Hanushek and Ludger Wösmann, who have implemented very interesting designs. There are textbooks like the one by Joshua Angrist and Johan Pischke, Mostly Harmless Econometrics. I think these are great books. And I think in particular, non-economists can benefit a lot from that, because economists, they ask different questions than educationalists. They are just interested in other things. They are more interested in institutions. Educationalists are more interested in classrooms and teachers. And these things are understudied, but there's the machinery, the methodology, or the methods that can be borrowed from other disciplines. And I think that there's quite some potential in applying these approaches to new research questions. So that is something which I think is not sufficiently done so far. However, then also, I think the last remark I want to do, I think what we should also do as educationalists is we should speak up and demand that education and educational policy has to be based more on evidence. Just a recent example, we all suffer from this pandemic, and imagine that we would now introduce a vaccination without any testing. We would never, ever do that. I mean, there are 2 countries who are doing that, I think, worldwide. But I think most would not do that for good reasons, because it is dangerous. But what we do in education, we just implement a huge reform and hope that it will improve, that everything becomes better. What we see in the international studies, this is often not the case. Internationally, student achievement is considerably stable, which means that all the reforms that take place everywhere are not as sufficient as the designers of these reforms hope. And I think we really need to speak up. We have to attack policies that are not based on evidence. We have to attack poor studies that are not well executed, that are not well grounded in theory. This is something that we really have to do. And I think the discussion today is important for that we start thinking about this question, how we produce evidence and what evidence is available.
But also, I think, let me add something to that. Agnes was also saying, how do we convince countries to invest more time, effort, resources, money into assessment? And I think the question is by clearly showing, convincingly showing the advantages of doing so. I mean, if we have to do research that has practical implications. I have lots of disagreement with colleagues in the university about what I'm going to say. But I think as social scientists, we have the ethical, moral duty to produce, to do research that has practical implications in society. Whatever we do has to have the final aim of improving society, in this case, education. Some people may disagree, and they would like to focus on other things. I do believe that we have this duty as researchers, and that can only be done, and it comes fits very well in the discussion within this workshop. It can only be done if we do not stop at applying rigorous methods to complex data, and that's it. I mean, it has a value in itself to develop new methods, but these new methods, we have to go the extra mile and discuss, develop the discussion, the conclusions, the interpretation of these results in order to have a practical impact in reality. And if we do that, if we manage to show that it's useful what we are doing, then we're gonna stand much better chances of having countries, policymakers, commit resources to keep on doing research and producing more and more useful information to do so.
Well, great. Thank you very much. I have some takes from this discussion. First of all, you're stressing, it has been stressed over the discussion, the quality. And I think this is a very important point, and the theory-based research, but also the aim to improve education and to reach out to the field and to show that these results are useful. And as for the implementation, I think it's very important for us to remember that, or to take from this discussion, that joint efforts of different stakeholders and researchers and creative solutions can be a way to on how to approach this this more causal questions, which not necessarily will then end up in very costly and time-consuming studies, but it can be also coordinated, and the resources that are available at the moment, they can also be used. So I think these are very helpful and interesting views. And for now, I would like to open the floor for the participants. We have still 10 minutes, so there is not much time, but I would encourage you to use the time. If you have something to add to this or a question that you would like to ask, please feel free to interfere now and open the microphone, open the camera, introduce yourself, and then you can go ahead.
Well, probably just something that I was thinking when Rolf was talking about creative ways of combining data and methods. I would also like to encourage everyone to combine with there are some other very interesting things that are being done using, for example, machine learning with large-scale assessments. One of the main limitations for machine learning techniques or methods is that there is you need really huge data sets in order to make them work. But now we have, as Rolf was saying, with things like Teams and PISA, that we have more than 20 years of data for so many countries. I think now is something that can be done combining this machine learning with international large-scale assessments. And the other is about methods. It's methods from econometric methods are very useful, but I have seen also some other things that are very, very interesting, like sequence methods, things that come from biology, that they track cells, for example, in biology, that they are originated in one part of the body and that are meant to end up, let's say, in the liver or in the lungs, but at the end they are somewhere else. So you have this sequencing that you can also apply to education. And it's very interesting. So keep your eyes open when you go to a conference, when you read articles, when you watch videos. Keep your eyes open to try to import some different methods, different frameworks from other disciplines into this area, because there's future there. No, every time we are more and more people working on this data, on these topics. So we can and we should be coming up with creative ways of analyzing the data and making it useful for education systems.
Okay.
Can I add something now? I think I just one thing popped to my mind, and I mean, it's now going a bit in wild directions, completely different directions. But I think one thing that we haven't touched so far is in the context of causal analysis, but not only causal analysis, the issue of measurement error. And basically, the problem is that often we measure the constructs we are interested in with some error. There are different reasons for that. For example, when we think about student achievement, I may just have a bad day, so that introduces some error, or I just may be lucky and I just at random choose the correct answer, or I may be lucky that I get some questions that I know, even though there are many other questions that I would not be able to solve correctly. But also with questionnaire data, we have a 5-point Likert scale, but actually we would need a finer graded scale, for example, 7 points or whatever, you know what I'm talking about. So that's measurement error when I collect data, and that's almost always the case. The problem is now, if I have two variables that are in theory, and just imagine that we would have two measures that are without any error, and the correlation between these measures is, say, 0.5. But now we have some measurement error. And so we have some random noise in the first measure and in the other measure. That means the correlation, which is actually in reality 0.5, but we do not have the measures, not the variables that measure these variables without measurement error, but we have measurement error. What will happen is that the correlation would vanish. It would become smaller. What we will typically observe then would be a correlation of, say, 0.3. And the only reason is that there's this measurement error. And that's a very frequent problem that we experience almost always. And multi-level modeling cannot really address that. Measurement error remains. But one thing that we can do is that we can use latent variable modeling. And we can combine now, for example, factor analysis or confirmatory factor analysis with multi-level modeling. And if we do that, we can get rid of the measurement error. And I'm just stressing that because measurement error is always a problem. And typically all estimates, whenever measurement error is there in place, which is almost always the case, the estimates of our effects will be biased towards 0. So effects that are very positive will become smaller. Effects that are very negative will become smaller. So they approach 0 if the measurement error increases. So what we can do in this context is to use this multi-level structural equation modeling, where we have the measurement models and for the latent variable, and they circumvent this issue of measurement error. And then we have the multi-level structure for the estimation of our effects. And I think this is an extremely powerful tool. And I mean, you may now wonder why I'm stressing that. I'm stressing it because it is so important, but also because there will be an additional workshop, if I'm informed correctly, Agnes.
Yes. Yes, thank you for bringing this up. Actually, this gives me a good opportunity to advertise a little bit. At the end of November, there will be another virtual workshop, and it will focus on structural equation modeling. And of course, on the last day, we will also introduce the multi-level structural equation modeling. And we are really looking forward to meet many participants from this workshop in the other workshop, because we figured out that many of you all aim or plan to be at this second workshop. But of course, we would be happy also to have more participants for the second workshop. So yes, thank you.